Here's how the product works in practice. Imagine a Web3 product team monitoring a DeFi wallet that suddenly interacts with an unverified contract. The system detects the transaction, scores it against known risk factors like contract complexity and historical behavior, flags it as high risk, and triggers an alert. The team investigates via a dashboard showing the transaction's path, related addresses, and a breakdown of why the score was assigned. They can then whitelist the activity if it's legitimate or block it if malicious. Inputs are raw blockchain data, wallet addresses, and transaction metadata. Outputs are risk scores, visualizations, and alerts delivered via email, Slack, or in-app notifications. The boundary is clear. The product observes chain activity, adds context, and surfaces actionable insights without managing funds or executing transactions itself. Under the hood, this is made possible by a deliberate stack. Hardhat and Foundry handle blockchain simulation and testing. Hardhat spins up local Ethereum networks for replaying suspicious transactions in a safe environment, while Foundry's fuzz testing uncovers edge cases in how wallets interact with contracts. These tools ensure the risk model is trained on realistic scenarios. Google API Python client bridges the product to external services like sending alerts via Gmail or logging incidents to Google Sheets for audit trails. It's not the flashiest part, but it's critical for integrating with teams already using Google Workspace. The UI repository powers the dashboard, rendering clean, customizable components for visualizing risk scores, transaction graphs, and historical trends. It's designed to be tweaked without reinventing the wheel. Finally, Umami tracks how teams interact with the dashboard itself, measuring which features are used most and where users get stuck. This feedback loop helps prioritize improvements without relying on invasive analytics. Each repository serves a single purpose, but together they form a chain of trust. The blockchain tools verify what's happening on-chain. The API client connects to off-chain communication channels. The UI makes data digestible, and Umami ensures the product evolves based on real usage. There's no magic, just solid engineering choices that align with how Web3 teams already work. When a transaction scan or API call fails, the system applies an exponential retree with cached fallback to maintain continuous monitoring. When a wallet address initiates a transaction on Ethereum, the data flow begins with Foundry's CAST tool monitoring the network, parsing the raw transaction data. CAST decodes the call data, checks the sender's history, and flags anomalous patterns like rapid-fire transfers or interactions with unverified contracts. This initial assessment triggers an event that's picked up by Hardhat, which spins up a local fork of the mainnet using its built-in network simulation. Hardhat executes the transaction in an isolated environment, verifying gas usage, contract interactions, and potential reentrancy risks against predefined test suites. If the transaction's risk score exceeds a threshold, Hardhat logs the incident as a high-risk event and passes the transaction hash, timestamp, and scoring metadata to a Python service. This service uses the Google API Python client to authenticate with Google Workspace, checking if the wallet address matches any in a restricted list stored in Google Sheets. If it does, the service constructs an alert payload and sends it via Gmail API to the Web3 team's notification channel, embedding details like source destination addresses and contract checksums. Simultaneously, the system persists the validated risk data into a PostgreSQL database. Umami, acting as the analytics engine, tracks this write operation, recording the event's timestamp and severity for later trend analysis. The Shadchan UI framework then consumes this data through REST endpoints, rendering real-time dashboards that show wallet risk heat maps, transaction timelines, and drill-down contract inspection panels. Each UI component is pre-styled but extensible, allowing teams to customize risk visualization without rewriting core logic. Service boundaries are strict. Foundry handles chain data ingestion. Hardhat manages execution simulation and testing. The Python layer orchestrates external API calls. Umami tracks operational metrics, and the UI framework abstracts front-end rendering. Storage entities like risk assessment and wallet profile are shared via JSON schemas, ensuring consistency as data moves from blockchain analysis to human-readable alerts. This separation lets teams swap out components like replacing Gmail alerts with Slack bots without disrupting the core data flow. The MVP starts by scaffolding the core risk scoring logic using Foundry's Forge. Spin up a local node with Anvil to simulate chain activity without mainnet costs. Write initial tests in Solidity to validate wallet address scoring based on transaction patterns, contract interactions, and balance anomalies. Parallel to this, set up Hardhat for cross-testing on Goerli testnet to catch environment-specific quirks. Use Hardhat's task automation to compile and deploy test contracts that mimic high-risk behaviors like flash loan exploits or suspicious token swaps. For the backend, scaffold a FastAPI service to handle chain data ingestion. Use the Google API Python client to authenticate team members via Google Workspace accounts, ensuring only verified team leads can trigger manual investigations. Structure the scoring engine as a stateless function that takes a wallet address and returns a risk score between 0 and 100, along with supporting evidence like suspicious X hashes or token transfers. Mock this with hard-coded examples initially, then integrate with a blockchain explorer API like Alchemy or Infura. Local development uses Foundry's Anvil as the default chain, with the UI running on Vite or Next.js using the Shatchen UI components. Configure Umami via Docker Compose for local analytics, tracking dashboard usage and risk alert patterns. Set up a cron job or async worker to periodically scan wallets added to the watchlist, updating scores and triggering alerts if thresholds are breached. For testing, use Foundry's Cast to simulate malicious transactions and verify the scoring engine flags them correctly. In production, deploy the scoring service and UI as Docker containers on a cloud provider like AWS or GCP. Use Hardhat to deploy a monitor contract that stores whitelisted wallet addresses and risk thresholds on-chain, allowing teams to update parameters without redeploying the entire system. Set up a PostgreSQL database for storing historical risk data and alert logs. Use the Google API Python client to send email alerts via Gmail API when risks are detected, or create calendar reminders for manual reviews. Umami runs as a sidecar container for self-hosted analytics, tracking which risk metrics teams engage with most. Background jobs are handled via Celery or Redis queue, pulling from a priority queue of wallets needing analysis. The system batches requests to avoid hitting blockchain API rate limits. Monitoring uses Umami's API to embed risk score dashboards directly into the product team's workflow. Security-wise, ensure all Google API credentials are encrypted at rest and accessed via secret manager services. Regularly rotate keys and audit access logs through the UI's Umami integrated audit panel. This setup balances speed, accuracy, and team collaboration from day one. The final piece ties together monitoring and analytics. For real-time risk alerts, the backend uses Hardhat's debugging tools and Foundry's Cast to query chain data, while Umami tracks user activity and dashboard usage. Deploy Umami via Docker Compose by running Docker Compose upd, ensuring Node.js 18+ and PostgreSQL 12+ are available. Set environment variables like database URL and API URL in env to configure the database connection and internal API routing. Umami's default admin credentials are username admin and password Umami, but these should be changed post-deployment for security. The UI components from Shatten's library are customized using Tailwind CSS classes and configured via props documented in their UI framework. For example, a risk score visualization might use their chart component with dynamic data props fed from the backend's risk assessment API. Google's API client handles authentication for third-party integrations, like linking wallet alerts to Gmail or Google Drive. Initialize it by installing Google API Python client, setting up OAuth credentials in the Google Cloud Console, and enabling relevant APIs. Note that this library is in maintenance mode. For new projects, consider Google's Cloud Client libraries instead. All components are licensed under permissive open-source licenses. Apache 2.0 for Hardhat Foundry, and Google's client, MIT for Shatten UI and Umami. Self-hosting costs depend on infrastructure. Umami's Docker setup is lightweight, but real-time blockchain monitoring may require scalable backend resources. To start, deploy Umami with Docker Compose upd and explore the dashboard then integrate Foundry's Cast to fetch on-chain data. One question: how would you handle rate limits when querying Google APIs for wallet alerts?